Hi, welcome everyone. So in this video, we'll discuss about how to write a FORTRAN program to study the growth and decay of current in an RL circuit using RK method, and followed by the graphs which shows the comparison of the calculated data and the actual variation from the formula. Okay. So consider an electrical circuit with a voltage source attached in series to a resistor and a conductor. Such a circuit is called LR circuit. And for series connection, for example, using Kirchhoff's law of electric voltage in circuit, we may write VR plus VL is equal to V. VR is voltage across resistance, voltage across inductance, and this is applied voltage. So on rewriting this equation, so we have V minus VR is I into R, and VL is L di by dt. So this is the rewritten form of first equation, and we simplify it further by writing it as di by dt is equal to R by L in bracket V by R minus I. So this is a differential equation in which I is a dependent variable and t is an independent variable. So this is a first order differential equation which we have to solve using RK method. So in this equation, V, R and L, these are the parameters of the circuit. That is how much voltage you are applying, how much resistance you have taken, and how much inductance you are used. The actual formula in LR circuit for growth current derived by the actual solving the circuit, it is I as a function of t is equal to V by R in bracket 1 minus exponential minus R by L into t, and for decay for the same circuit it is I as a function of t is equal to V by R exponential minus R by L into t. So these are actual formulas. So the boundary conditions applied for these equations are, that is for growth, at t is equal to 0, current is 0 because it is starting, and when t becomes infinity, it attains the maximum value I is equal to V by R. Similarly for decay, as it is decaying from a particular value, so we say that at t is equal to 0, I is V by R, and at infinite time, current becomes 0 inside the circuit. Okay, so these are the boundary conditions for growth and decay. For writing the program and executing the program, we use the same compiler as used in the other video. You can use any compiler available online. You don't need to install the compiler on your system. So as an example, I have used this example FORTRAN compiler. Snapshot is shown here, and in this this black region is used for writing the lines for the program, and this green button here is, on which run is inscribed. So you have to click that button for executing the code. Okay. So now procedure for writing the code is: step 1, feed the values of the dependents V, L and R. These are dependent on the circuit which you are using. Then apply RK4 method. Since RK4 method is a very well known method for solving the differential equation, so I'm using RK4 method here. For details of RK4 method, I have made a separate video based on RK methods. So if you have any doubt regarding RK4 method, you can watch those videos for further details. Okay, so we have to apply RK4 method for solving differential equation for growth and decay of the current with the particular boundary conditions. Then plot the related graph from the data obtained by actually using the FORTRAN program, and calculated also from the formulas. So we have to compare both the outputs. So to begin with, I have named the program RKLR. RK is RK method, LR is this name of the circuit. So RKLR is the name of program. Implicit none means no variable has to be defined by default by its first character. So, and real these variables, and integer these variables. So while writing the program, you can also define them as they are appearing in the program. Okay, so like I know how much variables I'm using in the beginning, say for example 4 or 5 variables, but I don't know, later on I come across during writing the program that I need another variables, maybe real or integer. So you can define them later on as well. H is 0.01, it is step size, and value of L, R and V I have already defined: inductance, resistance and voltage for a particular circuit. Then I have written the program for growth. Boundary condition is t is equal to 0 when I is equal to 0. So I've started with this one, and this is write star comma star on the screen current and corresponding time and corresponding current. And this is a do loop because I want to draw the graph, so I have started the time from 0 up to 200 in the steps of 0.01. So first is 0.01, then 0.02, 0.03 and so on up to 200. And these are the this is the method for RK4 method, where we have to define S1, S2, S3 and S4 based on the differential equation. So these first you have to solve that equation on a paper, and then later on use that equations while writing the code. And finally, we have defined S is equal to S1 plus 2 times S2 plus 2 times S3 and plus S4 divided by 6. So this is RK4 method. Remember, here I have used H by 2 point, not H by 2, because I have already explained in the videos of introduction to Fortran that what is the difference between writing 2 and 2 point or 2.0 in the denominator of an expression. Okay, so then I have given an increment in time. First it was started from 0, now time is 0 plus 0.01, so new time is 0.01, and now current is I plus S into H. So this is RK4 method final formula. I is equal to I plus S into H. S is given by this. So write T and I and N2. So this is the solution of differential equation for growth of this current. Then in continuity you can write the same lines for decay as well. So boundary conditions are at t is equal to 0, I is V by R. Okay, and later on we define V as 0 because the applied voltage now has removed from the decaying circuit, so V has to be 0. But what is the actual current at times t is equal to 0? That is at the time at which you have removed the applied voltage, it is V by R. So that is why we have kept I is equal to V by R, and later on we put V is equal to 0. So it doesn't mean it makes current is equal to 0. V has certain value which is 12 up to this line, and after that it becomes 0. So current has non-zero value. Similarly, write t comma I, and the same lines as we have discussed in growth section. So same, everything is same, just you have modified the boundary conditions. Okay, and you have solved the differential equation using RK4 method and N2, and then stop and end program with the same name. And these are just these stars are these are just for separating or giving caption or titling to the sections. Remember that should start from exclamation sign or comment sign. Okay, so that program do not consider it as an executable line, so it is only comment line. Okay, so you can made this program in a different ways. So for example, you notice that in growth and decay, these 5-6 lines or this do loop, they are common. So you can write a single paragraph, and you can ask the user whether you want the circuit for growth or decay, and depending upon his answer you can change the boundary condition and use same set of section for solving the differential equation. So this is an exercise for you as well. You can write this same program with less number of lines. Okay, so try it your own. Now after pressing the run button, we have data coming onto the screen. When we plot this data, so with a step size of say 0.01, these are the lines for growth and decay of the current, and you see that there are 2 lines for growth and 2 for decay. One is from formula and another one is from the Fortran program. So you see that they are not completely overlapping with each other because of step size. See, if I increase the step size like this, they will completely overlap. So in case of increasing step size, your accuracy will be more. Okay, so these are the formula. This number 2.4 or 50, they are calculated by putting the value of V, L and R. Okay, so this is how RK4 method works in case of solving the differential equation for current with an independent variable of time. So thank you for watching this video.